In our last video, we applied the tool of constraint optimization on the production function, the Cobb-Douglas production function. Now we are going to use the logarithmically transformed version of the um, Cobb-Douglas production function. So how we can calculate the logarithmically linearized version? We can simply take its natural log. Here we have done it by using the laws of logarithm. We have taken the log of it. Once we do this, we have a budget constraint as well, and using both of these we can get the Lagrangian function. And once we have the Lagrangian function, we can take the first order derivative with respect to x, y and lambda, which will give us the three first order conditions. So we have found these three first order conditions, out of which the first of two can be chosen for finding the value of lambda, and then we have this budget constraint. So finding these values from the first two equations, that is equation 1 and 2, will give us these two equations. So we can equate, and lambda will be removed and the remaining terms will appear. Out of this I can extract one of the unknowns, that is y, and now I will name it as 4, because this equation number 4 can be substituted here in equation number 3, which will give us this form. And you can see the value of y is substituted. Then cancellation will lead us to this form. Also we have shifted these two terms on the right hand side. This is why they are here written here, as well as we have taken x as common factor from both these terms, so it comes out because we are in search of the value of x. So in the next slide you can see that gradually we are extracting the value of x. Now we can call it the critical value of x, and this is the first of them, and definitely the second one can be found by resorting to the equation number 4 and putting the value, that is critical value of x, in it, and we will get the critical value of y. So critical value of x is found. We have substituted here. Simplifying cancellation will lead us to the critical value of y, which is equal to this. So now we are having both of the critical values for this Cobb-Douglas production function, or even we can do this for Cobb-Douglas utility function. We know for Cobb-Douglas production, strictly speaking, alpha plus beta will be equal to 1. So when this happens, instead of these two terms in the denominator, we will write 1, and definitely it will appear like this: alpha into beta divided by px, and this will become beta into b. This is b, not beta, and beta into b over py will be the consequence of it, because alpha plus beta now is reduced to 1. So this is a simpler version of a strictly defined Cobb-Douglas production function, and you can see that logarithmically linearized functions, they can also be solved by using the constraint optimization, and this can give us results in a way which is very popular in economics, that is by linearizing the given function, because most of the economic analysis is linear in nature, as it is easier to understand and interpret. Thank you.